The compute part of Hadoop supports distributed computing at high scale. To query data in Hadoop, you need to use a particular programming style called MapReduce, which we'll look at in detail later in the module. With MapReduce, a single query gets deconstructed into a set of tasks which can be run concurrently. In Hadoop, the compute engine which manages those tasks is called Yarn, yet another resource negotiator. Yarn follows the same master-worker architecture as HDFS and typically shares the same machines. So the server, which is the HDFS name node, also runs the Yarn master service called the resource manager. And the workers, which run the HDFS data node service, also run the Yarn worker service called the node manager. Yarn's role is to receive a MapReduce job from a client, break it into many tasks, and distribute those tasks around the cluster as efficiently as possible so the job completes in the shortest time. Yarn monitors running tasks and queues tasks which are due to run, so when one task completes, the compute capacity it was using becomes available and Yarn schedules the next task from the queue. The goal is to utilize the cluster as much as possible. So if one job can be split into 120 tasks, which each take about 60 seconds to run, on a small cluster which can run 20 tasks concurrently, the ideal runtime for that job is 6 minutes. If you ran the same job with a minimal cluster that can only run one task at a time, it would take 2 hours. And on a large cluster which can run 200 tasks concurrently, it would take 1 minute, with the cluster only 60% utilized if there are no other jobs running. Yarn manages all the resource allocation and monitoring, so your code doesn't have to. The MapReduce job, which takes 1 minute on a large cluster and 2 hours on a single machine, is the exact same packaged code. So as a developer, you're free from the complexity of managing a large distributed process. You just focus on the data problem that you're solving. When you submit a job to Yarn, you send your MapReduce package to the resource manager, and it creates an application master for that job, which is a process that runs on one of the node managers, and it's what actually manages the job and all its tasks. While there are more tasks to run, the application master requests resources from the resource manager. When compute capacity is available, the resource manager tells the application master which node manager it can use to allocate the new task, which could be the same machine where the application master is running, or it could be a different worker. When all the tasks are complete, the application master tells the resource manager that it's done and it's going to shut down. And then the resource manager flags the job as complete back to the client, and it has all the compute capacity that the job used available to reallocate. There are quite a few moving components here, but we need to understand them to see what Yarn does when we send it work. And next, we'll see that process happening in practice.